Hello, everyone. Welcome to today's session on applications of trigonometry. And today we are going to cover the topic height and distance. Okay, so we will see the problems on heights and distance, and we will apply the knowledge that we have learned on trigonometry. Okay, so this is applications of trigonometry. So whatever the knowledge that we have gained in the trigonometry chapter, that we are going to use here. Okay, so before we get into solving the problems using trigonometric ratios in right angle triangle, first we need to understand two concepts here. What is angle of elevation? And then angle of depression. So if we look at in our day-to-day life, whenever we have some tall building or some tower, if you want to see at the top of the tower, we have to raise our head and see to the top, right? So for example, let's say this is the tower or a building, right? And you are somewhere here, for example. So you're standing somewhere here. So how you see this from your eyesight, right? So you need to see to the top. For example, if this is the tower, right? So now this is the horizontal distance between the tower and where you are standing. And this makes some angle, right? So this line through which you are able to see the top of the mountain or building or a tower is called line of sight. Okay, and this angle, angle A or angle theta, that is called angle of elevation. So when you are seeing at the top of some object, then that is your angle of elevation. The angle with which you will see, that is, this theta is nothing but angle of elevation. Understood? This is line of sight. This is angle of elevation. Right. Now what happened if you are looking at, if you are at the top of the building and looking at some object on the road, right? Let's see. So for example, this is the building, okay? And there is some bus or something, some vehicle is here, right? If you are at the top of the building, right? And you are trying to look down to this, which is at certain distance, right? So if you draw a virtual line here, this is parallel to the horizontal. And this angle, and this is still line of sight. The line which makes you to see the object from the position you are, that is your line of sight. And this angle theta is nothing but angle of depression. So you are looking down from the top. So that is angle of depression. When you are looking up, that is angle of elevation. So if this angle is theta, this angle is 90 minus theta, right? This is right angle triangle. If that is 90 minus theta, then this is also theta. Okay. Based on these two principles, we will be able to solve various problems. Okay. So first, let's understand what is angle of elevation, right? When you are looking from the bottom to the top of any object, a building or a tower or a mountain, the line joining your eyesight and the top of the object, that is your line of sight. And the angle that that line is making with the horizontal. So with the horizontal, the angle that line of sight makes, that is theta, that is your angle of elevation. And similarly, when you are at the top of an object and trying to look something down, so then the line joining your eyesight and that object is your line of sight, and the angle made by that line with the horizontal is your angle of depression. Okay. So if you remember these principles, then we can see how to solve the problems. So one hint here is the angle of depression here is nothing but this angle. Both the angles are same. This angle and the angle of depression are same. So based on that, we can solve the problems. So let me take some problems that we will have from, yeah, let me take the screen print of your problems. Yeah, let's say this is what I have. Okay. Like this, you'll get the problems. Okay. So let's check any problem, right? Let's take the first one here. A circus artist is climbing 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. So here the diagram is also given. So a circus artist is climbing the rope, which is AC, which is 20-meter length, which is tightly tied to the top of, where is it is tied? Top of the pole. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. So the angle made by the rope is AC, and that is making an angle 30 degree to the horizontal. So I know this side AC, I know the angle made. They are asking to find AB. So this is simple sine theta, right? So I know hypotenuse, right? I know the angle. I just need to find the opposite side. So here I'll just apply sine 30. So what is sine 30 here in this triangle? Sine 30 is opposite by hypotenuse. Opposite is what? AB. By hypotenuse is AC. So what is sine 30 value from the table that we learned before? That sine 30 is 1 by 2, that equal to AB, I don't know. So I'll just keep as is. And AC is 20. So if I send this value, AB becomes 10 meters. So the height of the pole here is 10 meters. So now you understood. So we learned the trigonometric angles in trigonometry, the earlier chapter. So that knowledge we are using for these descriptive problems. Okay. So here the diagram is given. In the other problems, if you see, there is no diagram given. So you need to draw the triangle, and based on that, you need to apply the trigonometric ratios and find the unknown value from the known values. So here you need to have trigonometric ratios knowledge, trigonometric angles knowledge as well. And also you need to frame the problem and put that into a triangular diagram. Okay, so let's look at some problem where we need to draw the diagram. Okay, let's see which one we want to do. Let's do the fifth one. A kite is flying at a height of 60 meters above the ground. Okay, so when we fly kites during our festivals, right? So the kite is flying at a height of 60 meters above the ground level. Okay, the string attached to the kite is temporarily tied to a point on the ground. Okay, so the string is tied to the ground. The inclination of the string with the ground is 60 degree. So the angle of elevation is given, that is 60 degree. Find the length of the string, assuming that there is no slack in the string. Okay, very simple. So I'll do like this. Let's say this is my kite, right? This is where the kite is. So what they are saying, a kite is flying at a height of 60 meters from the ground. Let's say this is the ground. Okay, this is the ground. And the kite is flying at what? 60, right? So this is 60 meters. So kite is flying at a height of 60 meters from the ground level. And now the thread is tied to the ground. That thread is making an angle 60 degree with the ground. The angle of inclination is nothing but angle of elevation. Now, just note like you are any normal right angle triangle, denote the vertex. So this is A, sorry, that's not A. Generally, we took that as C, right? This is C and this is A. Now, ABC is the right angle triangle. So from the problem that they have framed, we just got into a right angle triangle, and we know the height, that is the opposite side we know. And what we need to find? The length of the string. Length of the string is what? AC. This is nothing but our hypotenuse. So now we know opposite side, we know the angle, we want to find hypotenuse. So what we can do, we can again apply sine here. Opposite and hypotenuse. Which trigonometric ratio is a combination for opposite and hypotenuse? That is sine theta. So I'll apply sine 60 degrees. Sine 60 degrees equal to what? This is BC is the opposite side by hypotenuse is AC. So what is sine 60? From the values, I know this is root 3 by 2 equal to what is BC? BC is 60 by AC. I need to find, so I'll keep as is. So if I just rearrange these values, right? So cross multiply. So AC becomes 60 into 2 by root 3. So 120 by root 3, or I can write this as 120 by root 3, or I can also write 120 as 40 into 3 by root 3, right? Then AC becomes 3, I can write as root 3 into root 3, right? So AC becomes 40 into root 3 meters. So 3 I can split into root 3 into root 3. The root 3, 1 root 3, 1, the denominator root 3 gets cut. So it is 40 into root 3 meters. So that is the length of the thread. So if they give the value of root 3, that is generally 1.732. If they give the value, you just substitute that value and multiply, you'll get some value, right? So that's how you can frame the, you can understand the problem, put that into a triangular form, and then see which trigonometric ratio that you can apply, sine or cos or tan, okay? Based on which sides you know and which side you need to find. If you know opposite side, want to find hypotenuse, use sine theta. If you want to find adjacent side, when you know hypotenuse, use cos theta. If you know opposite side, you need to find adjacent side, use tan theta, right? Okay, so we'll also see some other problem here, but I don't solve that. I'll give you until we draw the triangle, right? Okay, the sixth one. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. So here, the boy's height is also mentioned. That means we should consider that height as well. Generally, we ignore that height of the object. Here, the height is also given, so we need to consider that height as well. So a 1.5 meter tall boy, okay, is standing at some distance from 30-meter tall building. So there are two objects here. One is the boy, the other is a building. So let's say here is the boy, okay? He is standing at certain distance from a tall building, okay? So let's say this is the tall building, okay? So AB is the boy, the height of the boy, which is 1.5 meters. And let's say CD is the height of the building, which is 30 meters. Okay. So there are two, one boy is standing here and here there is a building, right? The angle of elevation from his eyes to the top of the building increases from 30 to 60 degrees as he walks towards the building. Okay. So the boy is here and initially he is now looking at the top of the building. Okay. So here you need to draw an imaginary line, horizontal line, so that you will get the angle of elevation. So this angle with the horizontal is 30 degrees when he is at this point. Now what they are saying, the angle of elevation from his eyes to the top of the building increases from 30 to 60 degree as he walks towards the building. Let's say after some time he has walked to till this point, right? So when he walked to till this point, this is where he will be. It's not coming as a straight line. Give me a minute. Okay. So this is where he is. The new position of that boy from A, B, C, D. So I'll just use EF. Okay. The new position of the boy is here at EF. Now from here, if we look at the top of the building, the angle of elevation has increased from 30 to 60 degrees. Understood? Right. As he walks towards the building, find the distance he walked towards the building. Now you understood? So this is the diagram. So first, getting the diagram right is a very important thing in solving these height and distance problems. Okay. So here, a boy is there, a building is there, the heights are given 1.5 meter and 30 meters. And from that point, he looked at the top of the building, that is 30 degrees angle of elevation. When he walked for certain distance towards the building, yeah, as we go closer, we need to raise our head to see the top. That means the angle of elevation will increase. As you move closer to the building or tower, your angle of elevation will increase. Remember that. Okay. Now, he moved to the position EF, and from there he looked at the top of the building. So the angle of elevation is 60 degrees now. So now there are two triangles here. Which are the right angle triangles? I would say this point EF, I would just depict this as G, the horizontal point, right? So initially, let's assume the distance between the boy and this is, let's say he has that distance is not given, right? No, right? So let's say this is some x meters, and he walked some distance. That distance also we don't know. So let's say the distance BF that he walked, that is y, right? The total distance is BD is x. So here we are assuming BD as x meters, and then BF where he walked, the new position distance from B is y. Then what is this df? Df becomes x minus y, right? If the total distance is x and this is y, this becomes x minus y. Let me check that. So this distance becomes x minus y. If this is x minus y, as this is a horizontal line, this is also x minus y. Do you agree? And similarly, if this is y, this is also y. So BD is x, that is nothing but AG also, right? This distance and this distance both are equal. So similarly, BF is y, so AE is also y. Okay, listen carefully. And similarly, DF is x minus y. The same case is EG. Now, which are the two right angle triangles here? I see these two triangles. CGA is one right angle triangle which has angle of elevation 30 degrees, and then CGE or CEG, that is 60 degrees. So I have two right angle triangles here. Delta CAG is one right angle triangle where the angle of elevation is 30 degrees. And similarly, I have delta CEG, that is 60 degrees. So I have two triangles. I know the height, right? So what other things I know? AB I know. AB equal to DG equal to 1.5 meters, right? So this I know. This is 1.5. The total is 30. If the total is 30, then what is the CG? CG is nothing but 30 minus 1.5, right? So CG equal to 28.5 meters. This is 28.5 CG. Now from this triangle, I can find from this, if I use the sine 30, right? So what is sine 30? What is the opposite side here? CG by, what is the adjacent, what is the hypotenuse? AC, but I don't know hypotenuse, right? So I don't think we can use sine here. So, so we need to use tan here because the relation is between opposite side and adjacent side, right? So in place of sine, that's where we need to make the decision like which trigonometric ratio we should use, because we are talking about the opposite side and the adjacent side. So instead of sine, I'll use tan 30. Okay, so what is tan 30? Tan 30 equal to opposite side. Opposite is a CG by what is adjacent side? AG in that triangle. So what is tan 30? 1 by root 3 equal to what is CG? 28.5 by what is AG? AG is nothing but X. So what is X? I got the X value now. X is 28.5 by root 3 meters. So I'll leave as is. Now, from this triangle, can I say what is this tan 60? Tan 60 is same, opposite is CG by adjacent is EG. So what is this value? 28.5 by EG. What is EG? X minus Y. So what is tan 60? Root 3. So what is X minus Y? X minus Y is also 28.5 by root 3. I know X. I know X minus Y. So I can substitute X value into that, right? So this is X minus Y. So the X minus Y value, oh, hold on here. So the X here becomes 28.5 into root 3, right? Not by. So into root 3 here. That's what I was looking at. Okay, so now I have X minus Y, which is 28.5 by root 3. I know X, which is 28.5 into root 3 minus Y equal to 28.5 by root 3. So then Y becomes 28.5 into root 3 minus 28.5 by root 3. So I can take 28.5 as common. So this becomes root 3 minus 1 by root 3. So if I take root 3 as LCM, then this becomes 3 minus 1 at the numerator. So that is 2 by 3. So this Y value becomes 28.5 into 2 by root 3. Okay, from here, I'm just using this space. So 28.5 into 2 is 57 by root 3. Okay, so Y becomes 57 by root 3 meters. Understood? So this is how we can solve the problems here. So the main key understanding here is from the descriptive problem, not only in this chapter, in every chapter, we looked at quadratic equations, polynomials. In every chapter, based on the problem, you need to depict a diagram. That diagram here is looking like this. So in that, you need to find which are the right angle triangles. From that right angle triangles, you just apply the trigonometric ratios, the appropriate trigonometric ratio. It can be sine, cos, tan. Okay, apply that and find the unknown values from the known values. That's what you will get it. So here the key is drawing the diagram, identifying the identifying the right angle triangles, and then applying the appropriate trigonometric ratio. And you also need to know the values of trigonometric angles. How much is sine 30, tan 30, all that stuff, right? So that's how we can solve these problems. So hope you guys understood. So the applications of trigonometry is simply applying the knowledge we learned in the trigonometry chapter in the descriptive problems here. Okay, so this is trigonometric applications of trigonometric ratios and how to solve the heights and distance problems. Okay. All right. So thank you. Thanks for watching this session today. And I hope you understood this topic and keep practicing. And I will see you next time. If you have any doubts, please contact me through my Urban Pro profile. Thank you.